Thanks, everyone, for joining us for the session today. Can I get a quick show of hands? How many came to our session on Tuesday about IIS? Great. Quite a few folks. Thanks. So just some quick intros before we get started. My name is Sean Egan. I'm a program manager on the IIS team. I've been working at Microsoft for a little over 10 years, with around a year working specifically on IIS.
Yeah, my name is Wade Hilmo. I am a development lead at Microsoft. My team is responsible for IIS, so everything you see here today is produced by the team that I work with. I've been at Microsoft for a little over 20 years, and about 15 of that I've been working with IIS. The first version of IIS I shipped on the product team was IIS 4, but I worked with the versions prior to that as well, so I've been there pretty much the whole way. So what we want to talk to you about this morning is some of the things that we've done for IIS 8, the new features we've added. We're going to have some demonstrations on it. This is kind of a continuation, building on what we talked about the other day. In that particular talk, we talked a little bit about scalability and cloud and how to scale IIS out to many machines. In this talk, we're going to get down into specific features and just new things that we've added for IIS itself.
Great. So we want to walk through some of those features in order to some sort of common scenarios that administrators have told us that could be made better. So we'll walk through some of our security features for better securing your web server, how to isolate tenants from one another with some specific hands-on stuff, and then we've got a new feature that's pretty exciting about improving that first start experience when a website is not running, and then that first request, and how we can make that a little more user-friendly.
Before we get started, I will say that when we go through our demos, they're very different topics. We're going to cover some things that are completely different. And so if during the demonstrations or discussion you have any questions, go ahead and feel free to ask at that time so we can talk about the answers right as we're talking about the feature itself. And then at the very end, we can have a final Q&A. But questions during the session are perfectly cool.
All right. So our first topic is about securing the web server. So we often hear from folks that there's issues with malicious folks trying to hit their server, and how do I prevent those folks from taking down my server or taking up a lot of server resources? Or how do I keep accounts from getting locked out if people are trying to brute force attack my server? So we're gonna walk through some features that we've done to help with that. So in IIS 7, we had static IP restrictions where you could manually set up some restrictions to block IPs that you saw were hammering your server. That was a challenge because you had to figure out what set of IPs those were yourself. You could go through IIS logs and things of that nature, but it was a fairly manual process and a little bit labor intensive to set that up properly and keep it tuned all the time. So in IIS 8, we've introduced dynamic IP restrictions that allows you to make those things very dynamic and do it automatically, so there's no hands-on work that you have to do besides the initial configuration. And so we can deny based on how many requests they have going at a time, frequency of HTTP requests, so that if folks are hitting your server too often, you can block them. And then we also allow you to customize the response. So instead of just doing unauthorized, you may actually send back a 404 or even abort the request, which makes it look like the server just went away. And most tools, when they see stuff like that, they'll think the server's gone down and they'll move on to some other target. So let's go ahead and jump into a demo of that.
Jump right into it. OK, so to start, let's take a look and see what our new user interface looks like for it. Thank you. Now I'm looking at a different screen. Excuse me a second.
Oh, yeah, it's making us do that.
All right. So this feature is set, either you can set this feature globally or you can set it at the website level. This morning we'll take a look at the website level. And it exists right in the same place that IP restriction has always existed. But now we have a new setting, Edit Dynamic Restrictions. On this dialog box, it's pretty straightforward. You see we can deny based on the number of concurrent requests. This is a good feature to use if you have a client who makes a bunch of simultaneous requests to the server, one thing that we've seen periodically is somebody will open up a connection to the server, and then they'll make a request and send data very slowly over the connection in an attempt to occupy that connection for a long period of time. What they can do today is with a single client, they can just make hundreds of connections to your server. By turning on this feature, you can limit the number of connections that a single client IP is allowed to make. So if you said, I don't want anybody making more than 10 connections, you could just enable this checkbox and set that here. This is pretty straightforward. I'll go ahead and show it. We'll turn this on. Then we'll bring up some browser instances. Bring up 4 of them since we set the limit to 3. And I have a little application on the server that I can show a delayed response. So we can just go to localhost. One of the first things I did with IIS was I wrote ISAPI and ISAPI extensions. So a lot of the features I write, I'll just do a quick ISAPI to make the server do something interesting. This particular ISAPI, I can give it a command and just say, suspend, take that request, and then just sleep. Suspend for a period of time and then come back. So if I wanted to sleep that particular request for 5 seconds, I could just put in 5,000. You'll see that we spin, waits for a while, and after a 5-second delay, it'll come back. Let's increase that a little bit to 30 seconds. Get all the browsers doing that. We'll send this one here. Send this one here. Send this one here. Now, if we go to the 4th one, we've already got this particular client's made 3 connections. So now he comes back, and we give him a 403.501 error. The dynamic IP restriction module has custom error codes that it uses. It uses 501, 502, 503. So you can go through your logs, and you can see if this feature is being enabled and if clients are hitting it. We have another feature in this which kind of shows up in the user interface here called Enable Logging Only Mode. What this does, we want to give people a chance to tune this without necessarily blocking their live production traffic. So if you turn on Enable Logging Only Mode, we will let all the requests run through to completion. So the clients will see the normal 200 responses. But in your logs, you'll see the 501 errors here so that you can determine if this feature is set to aggressively or if you need to back it off. Now, enabling the number of concurrent requests is really useful for the scenario I just described. We can do something more interesting. We get customers talking to us that talk about spiders, crawlers, screen scrapers, things that will hit the site, parse through all of the content on the site, capture it, and then do something else with it. In particular, sometimes we see that they don't necessarily honor the robots.txt. What we can do for that is we can look at the rate that a particular client is making requests, and we can throttle them based on the rate. I have a little demonstration I want to show on this. I have a little script. Close some of these down. We have a tool called WCAT, or Web Capacity Analysis Tool. This is the tool that we use internally for all of our performance testing to analyze how IIS works under load and how to make improvements to it. And what we can do here is we can generate some load to the server. In particular, I want to show you that this client has found our sleeper, and he now knows how he can make a request to the server that takes a half a second to resolve. And so he's going to assume, since he's found a slow page, he can hit that slow page really hard and try to consume all the server's resources. In reality, this is pretty hard to do on a production server. IIS is pretty robust. I've had to make a number of configuration changes to the machine, reducing queue sizes, limiting the number of threads we'll create to get into a situation where the script can actually consume the server's resources. Let me run this script and we'll watch what happens. So what's happening right now, the client is spinning up a whole bunch of virtual clients. Each of those virtual clients is hitting that page as hard as they can. And in a second here, the tool will dump out some statistics and show us how it's going. So it's happened right now, and what we can see is we can see that we're handling about 200 requests per second because I've limited the thread pool. And we can see also that we're sending out a bunch of 503 statuses. What the 503 is a 503 is because we can't keep the queue clear. And so this is what the 503s look like. And if you had other clients hitting your machine, they'd be getting this 503 error. So what I want to do now is I want to throttle this client that's hitting the machine real hard. And so to do that, we'll just go into dynamic IP. We're going to say each particular client is allowed to make 3 requests every 200 milliseconds. Any faster than that, we're going to fail them. So we'll just go ahead and say OK. Let's go take a look and see what's happening on our attack machine here. We see something a little bit different. When we look at the status, in addition to the 200s and the 503s, we now see 403s. 403 is the default response that we give to someone if they make requests too fast. But because we're throttling this client here, other people trying to reach the page or refresh the page, they're now able to get through. And so as long as I'm throttling this particular client, these requests are going to get through. If I come back here and I stop throttling while I'm still under attack, service is unavailable again. And so you can see here how this feature can offer some protection to the server to kind of isolate and push off a client that's hitting the machine too hard. Yeah?
How do you ensure that you don't block universities and other big places where a lot of users could hit the same website but for the same topic out, making it limit probably get
So the question is, how do we prevent users behind a proxy from getting caught up in this? And to answer that question, we do have something we call proxy mode. What proxy mode does, proxy servers that make requests will add a header called x-forwarded4 to the request. And then they'll append the IP address of the client. And that, as the requests go through multiple proxies, we'll build up a chain of requests, of IP addresses. When we enable proxy mode, we'll walk that chain backwards. And when we realize we're hitting a proxy, and we have to know what the proxies are. So we would need to know that university's proxy IP address. Presumably, if you get a lot of traffic from there, you probably would know that. Most of the time, we use the proxy feature for reverse proxies and load balancers internally, but it would work there as well. So we will treat the proxy itself as allowed, and then we'll go look at the IP address that the proxy gave to us, and we'll throttle on that. And so we do accommodate the situation that way. Okay? So that's what I wanted to show you today on dynamic IP restrictions.
Okay, let's go ahead and switch back to our slides. So there's more we can do in terms of security. So another common thing that we've heard from our customers is we need to do some security work on FTP.
So yeah, so we took this feature, this dynamic IP restrictions feature, and we started showing it to customers a couple of years ago. And the first question that they asked us was, that's really cool. When can I have that for FTP? And it turns out that FTP doesn't have quite the extensibility we need to do this. So we started looking at that. And then we started asking, why would you want this for FTP? And the specific situation we hear customers telling us about is clients that will try to brute force attack accounts on the FTP server by trying to log in repeatedly with a known user and different passwords. And so we added a feature to the FTP server to address that specific scenario.
Yes, we did. It's called FTP logon attempt restrictions. And so what this is going to do is allow us to block those sorts of things. Because what would often happen as an effect of trying to log in with a known account, if it was an actual Windows user account, that user would get locked out of the server. And so as people were brute forcing and trying a different password, you would end up locking out a real user who could then no longer do what he needed to do. So let's go ahead and take a look at what one of those attacks might look like and what our solution will do to help address that.
Okay, so I have an FTP server on this IIS machine, and I have a user account on there. The user account is called FTP user, and his password is very secure. It's capital P, an @ symbol, SSW0RD password, so he's able to log in. That's great. But his password's fairly simple. And so let's go take a look and see what an attacker might try to do with that. I have another machine. And on this particular machine, I have a little FTP hacker tool that I wrote the other day. What this guy does is you can run this tool, you can give it a host name, a username, and a password file. And the password file is just a list of common words. This particular one has about 800 words in it. If we look through it, we'll find at the very end it has FTP user's password. And so if I run this attack, it will be successful eventually on the machine. Let's see how long that takes. WaitH TechEd 1 is my IIS server. FTP user is the username. Here's that. We can see now that the tool's going to go through and it's going to try each and every password. That's from the file. It'll get through the list, and right about 10 seconds into it, 10 and a half seconds, it's able to find that the user's password was password. So we can actually, today in FTP and IIS 7.5, you can mitigate this kind of attack. And the way that you would do it is you would use the Windows feature to control the number of invalid logon attempts a user is allowed to have. And that's great. That'll mitigate this attack. But it has a side effect. And the side effect is it locks out that user account for a period of time. We can do better than that. So what we'll do is we'll go back to the IIS machine and take a look at our what we have in FTP. So we have FTP logon attempt restrictions. And what we can do here by enabling this is we can allow 4 maximum attempts in 30 seconds. And if you exceed that, we'll just disconnect whoever's trying to log in before they get a chance to even log in. We'll apply that change and see how it affects the tool. Go back to the other machine. We'll rerun this tool. And we'll see that it's going to continue to try. Now, this tool is a lot more malicious than most tools would be. Typically, and I had to resist the temptation the other day when I wrote this, typically the inclination would be to try, and when a server starts disconnecting you, just to move on. Say, I'm done with that server. I'm going to go try to attack another server. This tool is not like that. This tool is very persistent. It will continue to try a password, whether the machine connects or not, until it's able to actually get a successful or a failed logon attempt. And so it's continuing to try, even though I'm kind of flooding my little local network here, even though we're not getting a response from the server, it's going to continue to try. But even while this attack is underway, we can go back here. My laptop has been dropping keystrokes this morning. And log in. And so this user is able to continue to use the FTP server even though his particular account is being attacked. We can go back and check on the status of our attack here. While we've been doing this, we haven't really gotten very far. I can go turn the feature off and we'll see what happens. quick about going back here because it's now succeeding at going through running that again. Now, we've picked the defaults on this in such a way. Our goal is to make this easy to be on and not to generate support calls. All we're doing here is we're throttling the logon attempts. We're not actually blocking any accounts. So we're just slowing down attackers. And the goal here is to set some numbers for failed attempts in 30 seconds. Someone would have to be typing pretty quickly and repeatedly to even turn this feature on, to even hit this issue. And if they did, and they just waited a few seconds, they'd be up and running again without having to have anybody enable their account or talk to any administrator or anything. So the object here is to have a feature that can be turned on and really seamless and effective. So that's FTP logon restrictions.
All right. So now we want to talk a little bit about scaling your web server. And in particular, we want to introduce our new CPU throttling feature. So in an environment where you have multiple tenants or you even have multiple applications running on the same server, those applications or tenants can contend for resources. And they both want to use as much as they can sometimes. Or if you have a poorly written application, for example, it can accidentally use a lot of resources and then end up affecting other tenants or other applications. So we've done some work in CPU throttling to address that. But wait a minute, didn't we have CPU throttling in IIS 7?
We did. How many people have used CPU throttling in IIS 7 or 7.5? A few people. We don't see a lot of people because the feature doesn't really work very well. What we do in existing versions of IIS is we use job objects to keep track of how much CPU has been used. What we do then is we get a notification that says this process has exceeded its CPU usage. We need to do something about it. The only thing we can do today is stop serving requests. And so we will terminate the worker process. And so for some period of time after the CPU quota has been hit, every client that tries to hit that site or that application pool will get a 503 service unavailable. Not a very good experience. It does protect the server, but it doesn't offer the best client experience. We can do better than that. Going into IIS 8, we met with the Windows kernel team to talk about how we can manage load in a multi-tenant situation. They worked with us to create this new feature where we can set a throttle and have it apply dynamically and have a transparent experience to the client. All the client would see in this particular case, instead of errors, they'll just see that the server is only able to go so fast. We can demonstrate that and show what that looks like.
Great.
As I mentioned before, I do lots of stuff with ISAPI. So I have an application here called Spinner. Like Sleeper, you give it some time and it does something, but instead of just stalling the request, this is going to spin every single CPU on the machine that it can find up to maximum. So let's start the task manager here. Go into the performance view. You can see I've got a 4-core machine here. And let's just have him spin for, I don't know, 10 seconds. And now, as you can see, one poorly written application that goes into an endless loop completely consumes your server for that period of time. How many people have actually seen that happen, where a poorly written app takes out the server? Yeah,
Quite a few.
I figured lots of people would have seen that. So it's done spinning the CPU for a second. I have another site on this machine, and that site's in its own application, in its own application pool. www.contoso.com also has an ISAPI in it. We'll spin this for 30 seconds. When we run this, we'll see that we're spinning the client here. But now when we look at Task Manager, we're not seeing the machine spinning up to 100% CPU. And if we actually go look at, what's happening here, I'm sorted by CPU, we'll find this number here. It's up to 42, down to 23. It's bouncing around about 30%. Actually, if you were to look at this at a low enough level, you'll find that it's very steadily at 30%, but the sampling rate on Task Manager or on Performance Monitor will show some fluctuation in it. Let's take a look and see why that's the case. So we'll come back and look at Contoso's, actually we'll look at the application pool for Contoso. and we will see that I've set a CPU limit of 30,000%, 30,000 thousandths of a percent. There's actually, I won't go into why that's in thousandths of a percent, but it is. And I've told it to throttle. Previously, in earlier versions of IIS, all we had was kill. And what kill would do is you'd reach your quota, it would shut down the worker process, you'd see 503s, and the period of time that would happen was 5 minutes. And so you'd see the server out of commission for up to 5 minutes if you enabled CPU throttling. That's not the case anymore. There's a couple of other things on here. We've got throttle. We've also got something called throttle under load. What throttle under load is it says, hey, I've got a bunch of people on this machine, and I want to make sure that this particular user can't consume all the resources on the machine. But if the machine's not doing anything else, let them do what they want to do. So let's set throttle under load. And then we'll come back, we'll refresh spinner again. And we'll see that Contoso is now consuming virtually all the CPU. He's up to 99% of the CPU. Let's introduce some contention. Bring up another Internet Explorer. I don't think you can have a Contoso server without also having Fabricam. Before I hit enter on that, I want to make sure that we are still spinning on the Contoso side. Now we've got Fabricam running. And if we take a look, we'll see Contoso is now throttled back. He was at 100%. Now he's back bouncing up and down around 30% again. Contoso's consuming the balance of the CPU on this machine. So in this particular case, you can have a bunch of tenants on the machine. You can say 10% is the maximum they can have only when the server's under load. And then when the server's not under load, they get the same performance they do today. But as more and more contention happens on the server, we'll gracefully throttle each of these applications back so that they're not exceeding their quota, and we will do it without sending back errors to the client. So that's our CPU throttling feature.
All right. So application startup experience. How many people have ever tried to access a website and then sat there staring at a blank screen for a few seconds before it actually came up? Quite a few folks. This is a complaint we've often heard from our customers, and we've done some work in IIS 8 to help address that scenario. We call the new feature application initialization, and there's a couple of concepts that would be useful to understand before we actually get into the demos. So the three concepts are application start mode, application preload, and application initialization. They're displayed here in a particular order, but I'm actually going to talk about them in a slightly different order.
The order they're displayed here, this is the runtime order that they would happen going through the pipeline. But to understand the feature, it makes sense to talk about them in a little bit of different order. And that's what Sean's going to show you now.
Right. So the first one is application initialization. And what this really allows you to do is to customize that startup experience during an application startup time, which can vary, of course, by application. And so this is a developer-type feature where we let the developer of that application decide what's going to happen during that time where my application is warming up, where I'm doing ASP.NET compilation or filling memory caches and things of that nature. During all that startup work, what's the application experience that my customer is going to see? Each application can define its own behavior. The settings are in the web.config file for that application. And IIS helps with this by putting particular server variables in place so that the application developer knows what state his application is in, and when it's warming up, he can take action based on that fact. Application preload is a feature that allows us to start an application as soon as the worker process starts. So normally what would happen if a worker process is there, but the application's not running, you'd still have that slow startup experience. So effectively what we do here is we send a fake request off to the root of that application to get it warmed up as soon as that worker process comes online. If you were an application developer, wouldn't you want this for your application? Of course you would. So this is a server administrator feature. So this is in the application host.config file. So the server administrator can decide which applications are important enough in his environment in order to enable this feature. And one thing that's related to this that's pretty cool that we'll be demoing a bit later is that a new process and a recycled process behave slightly differently. So in the case of an application that needs to recycle, like the 29-hour periodic recycle or recycling for any other reason, before we take that old process down and replace it with the new one, we'll actually bring up the new one and do all of the warm-up work to it, do the preload, do the application initialization, and keep the old process around serving a request until that new one is fully up and ready to go, warmed up, and ready to serve requests. And to cap it off, we have application start mode. So this is an existing feature in IIS 7, but with these new things, application preload and application initialization really lights up and makes it a lot more useful. So what this does is allows you to pre-start an application pool without waiting for any sort of request. So once you've got an application pool running, if you enable preload, of course, we will send a request to the root of that application. And then if you've got application initialization enabled, we will do all of the warm-up work for that application. So let's go ahead and take a look at how some of these things work in practice.
All right. So before we get into this, I'm going to give a little confession here. A couple hours ago, we were in the speaker room running through these demos, and they weren't working for us. So we believe we've got them ironed out. But if it gets bumpy, you guys might get to see the development lead on IIS doing some real-time debugging in front of everybody. That might be kind of fun if that happens. But let me just go ahead. Let's just switch over to the demo machine and start showing this. This is the one feature. Since I'm the lead, most of my developers do all the work. This is the one feature I got to code myself. And it's probably the most difficult feature to explain and the most difficult feature to understand. So I'm gonna do what I can to try to explain it here. I have a blog series going on IIS.net, which Sean's going to tell you about at the end of the talk. I don't get a chance to blog too much, so I'm kind of in the middle of it. But let's just go ahead and take a look and see how this works. So this is an experience that a lot of you raise your hands for. We've got right now, we've made a request to the server. It's just sitting here spinning this. It's going to spin for a while as the application's doing its thing, and then eventually it'll come back and say the application is running. And so the whole purpose of application initialization is to address this experience. It turns out it's not a trivial problem to address. At the end of the day, if you have nothing running and it takes 2 minutes for your application to get started, there's nothing you can really do from a completely cold situation to get client requests getting valid response before that 2 minutes is up. So that's why we've kind of broken this problem down into several parts. And the part I want to talk about now is, wouldn't it be cool if there was a way that an application itself could define what its behavior is during that period of time it's not able to do its normal work because it's warming up? And so to that end, we've introduced the first part of the feature, which is the classic application initialization. And I'm going to show you now editing the web.config directly. We don't have user interface for this. It's possible to use the config editor for it. The reason we don't have a user interface for this part is we expect the applications themselves are best able to understand what they can do during the warm-up period. And so we expect an application to include in its web.config what to do during warm-up. So let's just go to the application's web.config. Before we do that, let's just take a look and see why the application is slow. So this particular application is slow because of this particular sleep that it's doing here. Most real-world applications aren't going to sleep, but what we do find, the most common situation for startup is in global ASIX during doing major compilation and doing major initialization before it's even able to take the first request. And that's what my app here does, but it simulates it. So the web.config here right now is empty. what I want to do is I want to turn on the application initialization feature. And the first thing I'm going to say is, during the period of time we're initializing, skip manage modules. And the reason that we do that is we need to bypass the global ASAX. Because if the global ASAX is allowed to run, we can't do anything until it's finished. So what I'm doing right now is I'm telling IIS, hey, when we're warming up this app, don't put any manage modules in. Just let the request flow straight through to the machine, straight through to the core web server. But we don't necessarily want to let a request go through. The default page for the application we're seeing now is called default.aspx. We don't want that request to flow through to the core server if we've skipped global ASAX. And so we have to have a way to say, do something else with these requests during that period of time. And what we're going to do here is we're going to say remap turns out I have a classic ASP page here, which doesn't require global ASAX. So any request, any managed code requests that come in during the warm-up period, we're going to send them to that ASP page instead of having them get processed normally. Now, I haven't actually said yet what it means for an application to warm up. The application developer gets to define that. And the way that you do that is you get to give us a collection of pages. This collection, in my case, it's just going to be a single page. You could put a dozen pages in here if you wanted. And warm-up is defined as the period of time from the first request we get that touches that application. We will take this default.aspx, and instead of having the request come in off the wire, we will inject it directly into our pipeline, and we will let it run through ASP.NET. If there was another one here, as soon as the first one was finished, we'd grab the second one in the collection, send it through, let it run to completion. The application is in the warm-up state until each thing in the collection has had a chance to have a complete response. And so for something like, we've been working internally a little bit with SharePoint, trying to get a better SharePoint startup experience. How many people run SharePoint? So we're working on improving the startup experience there. We have some pages we put in that will cause all of the SharePoint initialization to happen. And you could, for virtually any application, you could get a list of pages. And that's all we need for now. We'll save that. Now, the application's already been initialized because I just made a request to it a minute ago. So let me restart the web server. We'll come back here and let's look at what the difference in response is. So now we get a response back as soon as that worker process starts. Now, this isn't the full response that we would normally get. And the other interesting thing here is if you look at the timestamp, you'll see that it's rotating. We just have a simple refresh directive in the ASP page so that it just retries the page periodically. Once it's done, once it gets something back outside of the warm-up period, then we get the application is running. So this is interesting, but it's not all you can do with this. Imagine a situation where you had, say, a stock ticker. And let's say your stock ticker app took a long time to warm up. What you could do is when the stock ticker's running, it could cache responses into static pages. And then during the warm-up period, it could just reroute the inbound requests to the static pages until the application was fully warmed up. Once the application's fully warmed up, you could start giving out current data again, and it could update, the application could update its caches again at that time. You can't do that with what I just showed you, because what I showed you now is take any managed request and remap it to startup.asp. Downsides to that are, what if you have a native application that takes a long time to start up? What if you're using PHP and your PHP app has a long warm-up time? That's not a managed request, so that wouldn't work. What happens if you had 20 URLs on your system and you wanted each of those 20 URLs to be handled special during the warm-up period of time? That's another scenario you might want. What if you had a web service and during the warm-up period you didn't want to send back the application is warming up splash page because a web service won't know what to do with HTML? To do that, we have another tool that we ship for IIS called the URL rewriter. And the URL rewriter has the ability to look at an inbound URL and do non-trivial things with it. It can rewrite it based on a regular expression. It can remap it based on a table of one-to-one URL mappings. It can do different dynamic things with it. So we expect in most cases, applications will want to integrate with the URL rewriter. So let's take a look at that and see what that looks like. So I'll go back to my web.config briefly. I'm not going to use the built-in remapper anymore because that's not flexible enough for what we want to do. Save that. And then we'll go look at my app-init application. I have the URL rewriter installed on this machine. And let's create a rule. We'll start with a blank rule. And we'll just call this the warm-up rule. We want to take any inbound request, and we want to do a pattern match. And I'm just going to use regular expression by default. .* in regular expression says match anything. I have some conditions. Let's say I want to do this. One thing I haven't showed you, how do we know if we're in the warm-up period or not to do the rewrite? Turns out we create some special server variables that we put into the requests so you can determine what the rewrite state is. In this particular case, we're going to look for the app warming up. So any request that comes off the wire during the warm-up period will have this server variable set to 1. So this rule is only going to fire if app warming up is set to 1. So once warm-up's done and that collection of pages is run, this rule drops out. It doesn't run anymore. And I'm interested in remapping requests other than my start. I don't want to remap that startup.asp request, and I don't want to remap the JPEG that has my IIS 8 logo in it. So let's add some conditions for that. So let's say the URL does not match .star.jpg $. In regular expression terms, the .* says anything followed by .jpg, and the $sign says .jpg has to be the end of the string in order for match to happen. If you ever want to see how regular expressions work using this tool, we have the ability to test the pattern. So I have the regular expression here. Let's just do star.jpg without the $. And we see that image.jpg does match the test. We get a green checkbox. But also, image.jpg.txt is also going to match this test. So this is why we use the $sign. Oops, put the $sign here. Image.jpg still matches. Image.jpg.txt does not. And so this is a good way, if you're going to use the URL rewriter, to test the expressions that you're using. So this is what we want. So this will allow image requests through during the warm-up period of time. And we want to allow classic ASP requests through during that period of time. Now, we need to be careful here because if a request comes in and we don't remap it, it's going to try to run. Some ASP.NET applications will set something called run all managed modules for all requests. It's a configuration setting. And this allows things like ASP.NET Forms authentication to work even if you're using static files. So if that setting is set to true, every request is a managed request. even if it's for a static HTML page or something like that. So we need a way to do kind of that skip manage module thing in the rule conditionally. And so if we're going to rewrite a request, we can now go and add a server variable. So just like we put the server variable in called app warming up, that any application can read to see if the request is during warm up, we also allow people who create their own requests or remap requests, we allow them to add this server variable as a directive to say, hey, when you run this new URL, skip all the manage modules. I don't want to see them. I don't want them to run. So we'll add that in. And if all of that's true, let's make it startup.asp. And we don't need to process any rules after that. So I'll apply the rule. We'll start and stop the application again. We'll make our request. Got a 500 error. And the reason I wanted to show you this error is because if you haven't used the URL rewriter, or if you haven't used it setting server variables in the remapped requests, we have a security feature in the URL rewriter. Some server variables are security sensitive, and you don't want someone to be able to say, remap the request, and oh yeah, inject the magic doesn't need authentication server variable, and be able to skip authentication. And so in order to be able to set certain server variables, you need to an administrator needs to configure your URL rewriter to say, this is a safe thing to do. And so we'll go back to URL rewrite. We'll go in here and we'll say, I have a new server variable, skip. Skip manage modules. And I just told the rewriter that it's safe for someone to inject that server variable. So now that we've done that, make sure everything is not initialized again. Refresh the page. And does anybody see the error? This error I didn't plan on. You see it? I did. I forgot. I typoed it. Let's fix that. We'll go back here. Before we run this, I want to show something else. I mentioned before that we were having trouble with the demonstrations earlier today. I want to show you what I did to kind of figure out what was going on. We have a feature called failed request event tracing, and I happen to have that turned on. And what it does is it creates detailed traces of each request that meets a certain set of criteria. I've told it to trace all requests. And so we see a bunch of XML files that get created whenever I make a request. Each one of those XML files refers to one request. We also include a style sheet so that if you go through and double-click this, Internet Explorer will open it up. It'll use the style sheet to show you the events. What we use internally for debugging is a compact view. Let's hear it for IE. Let's close all the tabs. We'll try that again. Compact view.
No, not happy.
Excellent. I wasn't anticipating a demo failure in a product that I don't work on.
Do you try a different front log?
Huh?
Want to try a different log?
Let me open over. Sean's suggesting a different log file. We'll give that a try here. So that's interesting. What we can look at here is this log will tell us what the actual URL was. As we go through, the interesting things that I want to show are URL rewrite start, rule evaluation start. This one's interesting because it tells us that the rule name is app init. It tells us that the actual URL from the client is is8.jpg. It tells us that we're trying to match it. Here, we're doing the pattern match .star, and it did match it. And so what we would normally be able to go through is test to make sure each of these rules work correctly. I'm not going to spend any more time on this because it's not part of the demo, and I have IE not working correctly. But let's go through and see if my changes made the app work. Thank you for that. That's something to look at. Apply the rule. The other thing I didn't do is bounce the server. Okay, so now with the URL rewriter, I have application is warming up. It's going to continue to make the same things. But instead of just being set to remap manage requests, what I'm doing now is I'm doing my rewrite not based on whether the request is managed, but I'm rewriting it based on the fact it's not an ASP page and not a JPG page. I could set any particular set of URLs and remap some and not remap others. URL rewriter supports something called rewrite maps, which is basically a table. If I had 100 URLs, I could just say this URL change to this next one change to this, and have a one-to-one mapping. I could echo my entire application in cached pages if I wanted to. Another interesting thing, which we haven't had a chance to demonstrate here yet, because it just occurred to us a few days ago. How many people here have heard of application request routing, ARR? ARR is a load balancer that the IIS team produces that you can put on the front end of your farm, and it'll route requests to individual IIS servers on the back end. It's possible, using the URL rewriter, to write a rule that says, if the application is warming up, send it to a different server using ARR. And so then you get into a situation where if you have 5 servers on the back end, one of them goes down and then comes back up, so the application has to re-init. When a request reaches that server, we're in the warm-up period. It says, go use ARR. We send the request to a server that's already running. And so in that particular case, instead of showing a splash page that says we're warming up, we just send them to a server that's ready to go. So we expect people to use that one quite a bit. So I'm going to continue just by making some more requests here, because what we've addressed now is we've addressed this is what an application can do during that period of time to be responsive while it's warming up. But applications warm up at different times. So I'm just refreshing the page. I'm just continuing to make requests. Now, all of a sudden, I was warmed up and now I'm not. So what's happened here? Why am I seeing this? Let's go take a look at the application pool settings for app init. What I've done is I have set this application to recycle after 30 requests. And so when 30 requests are done, the old worker process goes away, a new one starts up, but that new one starts up, and it has to go through warm-up again. So the next question is, in solving this complicated problem, is how do I make it so that I don't have to wait for that new... I already have a worker process running, and just because I'm recycling it, it still works. So can I have a way to have the old one continue to serve responses until the new one is ready to go and fully warmed up? And the answer to that question is yes, you can. The way that we do that, let's look at the advanced settings for the app init application. and I want to bring your attention to preload enabled. I mentioned before we didn't have a user interface for all those web.config settings, and the reason for that is we expect the apps to provide that data. Preload enabled, we expect the server administrator to provide. So we've gone ahead and put that into the user interface. If we say set preload enabled equal true, what this means is it means whenever you start this application, whenever we start this worker process, find every application in it that's turned on this way, and just run all of their collection of warm-up requests and put them into a warm-up state right away without waiting for someone to make a request to it. If we do that, and we go back and start making requests, and you just have to trust me that I'm making lots and lots of requests, we should see that we're continuing to get application is running. I'm going to show you one more thing to look for. We were sorted by CPU. Let's sort by process name. Let's highlight our worker process. I'm going to continue to make requests. Let's watch this while that happens. We just had a change. I'm continuing to make requests. And what's happened is I've got two worker processes running. I'm continuing to make requests. Oh, one of them just went down. I'm continuing to make requests. The application's still continuing to run. What's actually happening here is what I just described. We see that it's time to recycle the application. So instead of just starting up the new one and sending requests there, we start up the new one, we wait for it to be done warming up, and then we start sending new requests to it. And until that happens, we continue to send requests to the old worker process. And so this way, we can make application recycles completely seamless so that the client never sees them again. So that puts two of the pieces into place. The final thing is, why do I have to wait for a client to make a request in the first place? And that's where the feature that Sean mentioned earlier, the start mode, comes into play. What if we could tell IIS, hey, if you're running, start that worker process. And then that worker process can go through and find its applications and warm them all up. We can do that. So I'm going to take the server completely down. And I'm going to go into the application pool settings for my app init pool. And I'm going to go down to something called start mode. And while I'm here, I'm going to tell you a funny story. We have two settings here. Start automatically and start mode. How many people know what start automatically does? Can I ask you what start automatically does? You had your hand up for knowing what it is? Because I'm willing to bet, I'll be honest, I didn't know what it was. Because it doesn't actually do anything. We put it in the user interface, we allow you to change it, but it doesn't actually do anything. Start automatically is a property that we set in the configuration to save some state that we want to use later. And so I don't know why we're showing it to you here, and there's certainly no case where you'd ever want to change it, but it has a name that's really confusing with this. I personally discovered this really, really late in the Server 2012 development cycle, too late to get it out of the user interface. So hopefully the next time we get to ship, I'm going to pull this out. What this means is start automatically is true. It means if you reboot your server, we will automatically start that application pool. If you turn that off, like this, we hit stop. We go back to advanced settings, and now we see start automatically should be set to false.
Yeah, it's up at the top.
There it is. Now it's set to false. So all it does is it tells you whether this button has been hit or whether this button has been hit. What we really want to do is we want to go into the app init pool, go to advanced settings, and what we really want to do is we want to change start mode from on demand to always running. What this says is this says, hey, if the web service is running, this application pool needs to be running all the time. If it stops for any reason, we restart it. If the web server stops and the whole machine reboots, we start it without waiting for anything to happen. So we'll change start mode to always running. And actually, all I'm going to do now is just sit in here and talk. I'm going to try to take up 30 seconds of talking, because by setting it to always running, even after I completely stopped, actually, you know what, I did completely stop the web service. Let me start it. The web service is now going to start running. Even though I'm not going to make a request, the worker process will come up. Preload is enabled for my application, so it'll go through, it'll find that default.aspx in the collection, it'll run that, it'll wait for all that to be done, and it'll take it out of the startup mode. So say you schedule this to happen at 2 o'clock in the morning or some particular time when your traffic is light. This can go through, you can install updates or do whatever you're going to do, allow the web service to come back up. No clients have made a request yet, but when the first client does come through, we're already running. So at this point, we've put enough pieces together that no client ever needs to see that startup period of time. It's a little bit hard to describe, and it's a little bit complicated because the problem is not trivial, and each application is going to require a slightly different set of conditions, which is why we give the web.config control over how to deal with the application. But if all the pieces come together, that problem is largely solved.
All right. Does that make sense to folks? Are there any questions about that? We know it's kind of a complicated topic. Yeah, got one back here.
I'm going to go back.
Okay. We didn't quite hear you. We'll be back in just a sec.
I didn't quite hear you.
So when I'm in my warm-up period, I don't want to, for example, show Google that particular screen. Is that something I do in the rules?
Yes. So the question, now I have a question. The question is, if I'm in the warm-up period, I may decide that a particular client, I might not want to tell a particular user that I'm in the warm-up state. And the example he gave was Google. If a Google crawler comes in, I might not want to show him that page. And the way you would do that is in the rules using URL rewriter. You could make a rule that was conditional on the user agent. And as soon as you saw Google's user agent, you could then allow that request to go through without rewriting it to show them this page. So that's a great question, and that's the answer to that one. Any other questions on application initialization?
Doesn't look like it. All right. Let's go ahead and switch back to our slides. Okay, so that's it for our feature demos. So in this talk, we walked through a number of scenarios that are real-world scenarios that our customers have told us that they care about. So we walked through security and how to block those types of attacks via dynamic IP restriction. And we also talked about FTP logon attempt restriction to prevent those kinds of brute force attacks on an FTP server, while also leaving the account active for the person who really should be logging in. And then we've talked about resource sandboxing with CPU in particular, and the advanced way we do that now relative to how we did it before, and the ability to be really flexible and have different size sandboxes for different tenants, so different applications or tenants can have their own sort of allocated bucket of CPU. And then we talked about how to improve the application startup experience through application initialization, and how a developer can manage that experience during startup, and an administrator can decide which applications are important and should be preloaded and started automatically. So I want to give a quick plug for some related content here. So this talk is the middle one there, 332. On Tuesday we did 331, which should be available as a recorded thing that you're certainly welcome to watch if you'd like. And then tomorrow, Wade is going to be talking about IIS Express for web developers and walking through what the IIS Express product is and how you can use that in your development scenarios. I think that's the end of day tomorrow talk. Yep. And I also want to introduce the IIS.net website. So IIS.net is our community site for all things IIS. So we've got a lot of documentation up there about how the product works, a lot of in-depth technical articles that you're not going to find anywhere else. A number of our product team members have blogs that are up there. So folks like Wade and myself have blogs. A number of our other developers, testers, and program managers also have blogs. And even some of our community folks like MVPs have blogs that are hosted on IIS.net. And so there's a constant stream of new content coming there about IIS itself and ways to better leverage the feature set and do some interesting things with it. We also have forums. So if you have questions about IIS, this is a great way to engage with the community and get your questions answered and help out if you are an expert and want to help other folks in the community. And all of our IIS extensions are available for download via this website as well. So the URL rewrite module that Wade talked about during this demo is freely available for download, and you do that on iis.net/download. Just a quick plug for submitting evals. We'd appreciate it if you will submit on an online evaluation for us. Let us know how we did, what we can do better. It's much appreciated. And with that, our contact information is up here. You should feel free to contact us, and we have a few minutes to take questions.
We take questions now. Sean and I will also be at Ask the Experts this evening, so if you want to join us there and chat about IIS, that'd be great. Question here? So the question is it possible to get IIS 8 running on 2008 R2 Windows? IIS, the full server, is a part of the operating system, and so any version of IIS is tied to the operating system that it ships with. Now, for development, if you want to be able to develop for IIS 8 features on an earlier version of Windows, you want to come to the IIS Express talk tomorrow, because IIS Express will install on anything back to Windows XP.
Yeah, we have one in the middle here.
The question is for dynamic IP, the question is it possible to put exceptions for certain IP addresses? The answer is yes. You can put exceptions in for either specific IP addresses or for IP address ranges. The dynamic IP module that ships in Windows 8 shares the exception list with the regular classic IP restriction rules. We do have dynamic IP restriction available as a download that runs on either IIS 7.0 or 7.5. If you install it on that platform, it doesn't share the exception list with the built-in feature, but it has its own storage for its own exception list. Yes?
Yeah.
What was the question again?
Do you log the IP exceptions? So if you find something scraping the site with different IP addresses, can you see when those IP addresses work?
The question is, for dynamic IP, when people are hitting, do we log the IP addresses that are scraping the site? The answer to that is yes. At the beginning of the demonstration, we saw the 500.501 error code. We do have a 501, 502, and 503 error that we use for different conditions. And so you can just go through with log parser or anything else through your logs, and you can see which IP addresses are actually tripping the conditions to cause IP restriction to fail. It's in the standard log, that's correct.
Yeah, we have another question in the middle. Hang tight for just a sec. I think we're having a little trouble here.
Yeah, we're getting background noise from behind us. So, the question is, have we thought about implementing SFTP? The answer to that question is yes, we have thought about it. The reason we haven't done it is, despite the name, SFTP is not actually FTP. The Windows networking team would be the one to implement that, and we have talked to them about it, but they've not done it, and I don't know what their plans for the future are. But it simply wouldn't fit in with our FTP server because it's a completely different technology.
All right, any other questions? Looks like not. Okay, we'll go ahead and wrap it up. Wade and I will be here for a few minutes if you'd like to come up and talk to us individually. And like he said, we'll be at Ask the Experts this evening. Thanks a lot for your time.